I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Simon Holloway, Commercial Director at Dynisma. On today's episode, we'll explore how Dynisma is enabling simulation and testing within new virtual worlds for a wide variety of vehicle types and scenarios. We hope you enjoy this episode. Simon, welcome to the podcast.
Hi, and welcome to everybody. Hi, Grayson.
It's great to have you here. Motorsport's cool. I've been to a few F1 races, and I'm a simulation geek. And you're combining the best of both worlds. You got a really great world-class simulation platform that's being actively used in motorsport. Now the curiosity hat goes on, Simon. How much training for motorsports races is now occurring in simulation?
So more and more is happening in the simulation and the virtual world, but not just for driver training. So obviously, a lot of people realize that the drivers use simulators to learn the tracks and to learn how to drive quickly on a circuit. But the simulators are now used more and more as an engineering and a strategy tool as well. So the realism in what we can create means that the engineering teams can really get the setups for the cars correct and get the best performance from the cars before they even arrive at the track for the race weekend. That's key. They have less and less time on the track nowadays. So, they need to, the first free practice session, like you see the drivers going out in free practice 1, the car needs to be at its optimum as soon as it hits the racetrack. And they achieve that by running lots of scenarios and lots of different setups in the simulator with the driver, get that feedback and get that optimum performance. So when they hit the track, straight away they're in the right window, and then they can just dial in the car for the conditions at the time and for the driver, and if anything has changed since they ran the simulations.
When they're preparing from an engineering perspective, are the engineers taking all the historical data, the weather data, the lighting data, all these, let's call it edge cases? Well, the wind could be a little stronger. Historically, it was this period, and putting all that into the simulation to properly prepare the driver for anything that might happen?
Exactly, yeah. And they do that in a number of ways. They do that both with and without the driver. So they do run some simulation programs, which is based on getting the optimum performance from the car. And that will take everything into account from local weather conditions, prevailing winds, track temperature, tyre performance, and obviously all the characteristics for the vehicle as well. Everything from the aero maps to the powertrain maps to, even the surface that we drive on. So all that information is taken together, and in a simulation, a static simulation or modeling that they do in the background, they will do that to kind of see what is the optimum setup for the car. The piece then that they really need our kind of motion simulator for is putting the driver into the loop of that performance. So it's all very well setting a car up to be at its optimum performance, but often that car won't be physically drivable by the driver. So then what they will do is use the driver in the loop simulator to get feedback from the driver on how they can make something that is drivable but still at its most optimum performance.
When the driver's in the loop and they're in your motion simulator, are they giving feedback to the engineering team, tweak this, modify this, or perhaps swap the tires? They don't like those tires?
Exactly. So what they will do is they will run the same thing they used to do on the track, they will run in the simulator. So they will have their racing engineers, they'll have a tire engineer, a strategist, even a driver coach, and they'll be getting feedback from the driver about what the performance of the car is, just like they would on the track. But we do record all that data as well. So just like the telemetry systems that we use in a race car, we have the same thing in the simulator. So we can record that data, we can look at what's good, what's bad, what's giving an advantage or a disadvantage, and then they can tweak those models to see what the performance is. So, they might want to change the aero balance, for example. So just in the front wing or the rear wing, they may want to adjust the roll bar stiffness or another element within the suspension to get a better performance. And they can also do some strategy work as well. So they may run the different types of tyre that they're going to run over a weekend to see what the performance degradation is or what is the best performance even with the tyres as well.
And they'll run the rain tyres versus the dry tires as well, then simulate that, trying to understand?
Yeah, we can do that, but also on the dry tires often have multiple different compounds. So you might have a soft, a medium, a hard. So they would possibly simulate those and get data from the driver about how they're feeling the tire is degrading, and therefore use some of that feedback in what they will decide to run as a strategy in the race weekend.
Different tracks, because racing is a global sport. different tracks, different compounds, different materials. Let's look at Sebring, for example. It's a World War II airfield, and it's bumpy. It's extremely bumpy. How do you take that bumpiness of Sebring and put it into the simulator to prepare a driver for that? It's called a different driving environment that they might traditionally be accustomed to.
So generally, there's two elements to the environment on the track side itself. There's the visuals and the thing that the driver sees. So what we do is we create 3D environments that the drivers can drive on, which show them a realistic rendering of the circuit they're driving and the curbs, the features. They can pick out the braking points that they would use, or the features they would use for braking points in the race as well. And those are recreated for each track. And we then display that to the driver, either on a projected screen or on a LED wall, just like they use in entertainment. The other element then, which brings in the bumpiness that you talk about, is that most of the tracks we use are LiDAR scanned. So we get very, very detailed information about both the surface of the track and any of the features on the edge of the track. So things like the curbs, the sausage curbs, any features that are within the circuit. What that does is it allows us to then put the interface between that track and the car is obviously the tyre. So we also digitally recreate the tyre in tyre modelling software and the interface between the tyre and that surface. So that gives us very detailed information about what's going to happen with the car and the performance in the car. So you can feel every bump and every small piece that you drive over. Our simulators work at very low latency and at very high bandwidth. So these are the things that then mean that information is really being felt by the driver when he's driving the simulator. So our simulators run about a 3 to 5 millisecond latency and anything up to 100 hertz plus in frequency, which means that every little feature that they drive over on the circuit comes through the vehicle model and is felt by the driver in the cockpit, just like he does in a real car.
How did the team at Dynisma, how did you engineer this, let's call it realistic simulation product that from what you are stating to me, it's clearly making your customers, the drivers, better drivers? Yeah,
so one of the key problems in simulation in the past has been that the actuation and the way that the simulators move has developed from things like aircraft simulators and that kind of thing. And these use lots of actuators, ball screws, gearboxes. And one of the problems is that these have inherent friction in them, which means that it takes quite a lot to even make them move. And this means that they tend to have quite high latencies and quite low bandwidths, which then means when you're driving the simulator, if the car starts to move, if you have a high latency, by the time you react to the car, the vehicle model has already gone off and you lose the car and it slides and spins. And the other thing is with the low frequency that they have, it means it often feels like you're driving on glass because it feels very smooth and featureless. With our high bandwidth and our low latency, it means that you feel every little vibration, every little movement, and that's what makes it feel just like a real car. And it gives the driver is able to then correlate what he's feeling with what he feels in the real car.
Let's take a naive driver sits in your simulator for the first time. What goes through their head? Do they question, okay, let's see. What goes through their head when the first time that they sit into the simulator?
So I think the first time they drive it is the realism of what they feel and how you actually feel it's like a car. And again, because the simulator feels very much like a car, you drive it like you would drive a real car. So in some ways, driving our simulator is much easier for a novice or a person that's not an experienced driver to pick up driving it, because it is just like them driving the car. With other simulators with the higher latency numbers, you end up having to teach yourself not to spin the car and to almost delay your reactions down. And the other problem with that is it's very easy to make the person feel sick, because when the motion that you're feeling and what you're seeing in the visuals is not synchronized properly, that's what gives you the motion sickness feeling. And that's why traditionally, even a lot of famous Formula One drivers don't like simulators. because they don't get that real feeling and they get that mismatch and sickness feeling. So often when they'll drive them, they ask for the motion to be turned off because it's better to have no motion than have bad motion.
Is the low latency, is that one of Dynisma's competitive advantages in the market?
It is very much, yeah. Our low latency, high bandwidth are our USPs in what we have, yeah.
And so you have a superior product in the market. Teams are using it. We'll get into automotive in a minute from an engineering perspective, but staying on the racing front, when did you notice simulation really starting to take hold with teams? Was there a certain period of time where it really started to be introduced, then it all suddenly accelerated as technology got better?
Yes, basically. So simulation's been around for quite some time in the high end of motorsports, so in Formula One, etc. And traditionally, the teams would always develop their own simulators. So they would try and develop the ultimate that they can in simulation, again, because they see it as being a competitive advantage. And with the way, for example, in Formula One, the way the regulations now mean that they get very little testing of the new car before the season starts. This season it's 3 days. So they get very little testing. To overcome that, they're using simulation to develop the cars and get the cars quicker and understand, what parts give the car an advantage, what parts to put on, whether that be aerodynamics or suspension and setup, so that, again, when they hit the track for those testing days, they're getting the most benefit from them. What's then happened is obviously Dynisma, we've developed our technology, which, a lot is designed from knowledge that our company and our engineers have had both working in Formula One teams and developing simulation. So we bought that technology to develop the ultimate simulator and something that's much more realistic. Because that's now commercially available on the market, we're making that technology accessible to all levels of motorsport, so not just at the high end. So yes, Formula One teams buy our type of simulator, and you'll see that on what's in the public domain. But now that's filtering down as well. So we have Formula 2 teams using our simulators. We have Formula E. We have World Endurance. It's filtering down through the formulas and bringing that technology really available to further down through the motorsport pyramid. What you'll also see is drivers a lot now using their own gaming simulators at the other end and gaining their own experience. Some famous Formula One drivers are often on social media showing them doing their driving and doing 24-hour drives and things like that. And again, they're getting, although they don't have motion in those, they are gaining an advantage again by using the digital twin of the racing world.
Yeah, I've seen videos on YouTube where individuals put on the goggles and they have fans blowing. These are amateurs and they get into it and they build their rigs at homes. On the racing pyramid, let's go all the way down to the bottom. A lot of professional drivers have started with go-kart racing and they've progressed their way up. Could the simulator go down to that level if somebody had the resources or the inclination to use it?
Yeah, definitely. I actually was talking recently with some people about how use of simulators, even at the lower end of karting, for example, could help train drivers and get drivers up to speed even that much quicker, because you're not limited at the time you're at the track or the weather conditions. I think karting still has a really good place in the motorsport ladder in real life, because you gain a lot from one thing simulator doesn't do is it doesn't give you the same level of adrenaline or the risk feeling. So because if you crash, you turn it off and you can start again. But so I think there is a certain element to within racing that real karting is really important, but simulation can also accelerate and help that career path in your racing career. What it also is it means that if you're used to using simulators or racing games, even when you're younger, if you do have a successful career, you are going to end up doing a lot of simulator driving when you get further up the tree. The Formula 2 drivers are often the simulator drivers for the Formula 1 teams. So it allows them to learn that and learn the techniques of simulation and the benefits from it right from an early age all the way up through the motorsport pyramid, because that's what they're going to be doing when they're old, in a higher career.
And one of the great things about simulation is you have a very large data set. Are the teams and the engineers going through those data sets to find potential optimizations of where they can look to improve the driver's performance all the way across the motor pyramid?
Yeah, exactly. So, for example, data logging was introduced back in the 1980s into motorsport, and very quickly that became apparent in karting, just the same as it was apparent in Formula One. So again, there the youngsters driving in go-karts get very used to analysing data and corner speeds and throttle and braking and lines, and that's something that carries on all the way up the pyramid to Formula One. So if you get yourself used to using that kind of information and analysing it and working with your race engineer or your data engineer, it's really beneficial in as you move up your career. I think as well, one of the things is it can help people that come to racing at a later date. So, especially in where you get the situation with female and male racing drivers. So, a lot of boys get access into karting from when they're 6, 8 years old, and they build a certain level of muscle memory when they're driving and they're racing. So when they are then in a far higher formula, they've already learnt this automatic reaction and this automatic, almost muscle memory. So their cognitive skills, they can be working on other things like race strategy and how they're going to get the most out of it because they're just driving natural ability. Unfortunately, in our industry, a lot of the female drivers don't get access or don't go karting at those younger ages and tend to come into the motorsport later. So one of the things the simulator can do is to help them accelerate that learning of the same cognitive skills and muscle memory that the younger guys have had in their progression. So it can almost help level the playing field later on.
Which is a really, really good thing. Are there any limitations to the type of vehicle that can be simulated on your simulator?
Not really. The vehicle model is basically models from engineering principles. So, the suspension travel, the geometry setup, the tyre performance, and those kind of things are modeled in digital simulation software. So, as long as you can build the model for the car and then get some correlation from the data to the real car, there's nothing really stopping you running a Formula One car and then changing the setup by press of a button and loading up a set of data for a GT car or a world endurance car. So exactly the same simulator in motion can support all those different types of model. So yeah, it has multiple uses across different formulas.
Let's look at it from a software perspective. Do the OEM sell a digital twin or digital model that can be loaded into your system, or do you develop that for your customers and clients?
So often our customer will actually develop them themselves because some of that is the USP to the customer. And saying that, those customers might be the car manufacturers anyway, so or the race car manufacturers. So they tend to create the models. And one of our uniquenesses in our simulators is we're all about creating the motion and giving realistic motion, but we're actually software agnostic. So if the team uses a particular piece of simulation software or a particular type of visual software, we just integrate that with our motion system. So we don't make the customer change their existing tools to achieve using a driver in the loop simulator. We integrate what they have so they're not having to start afresh with a new tool set.
So that's another competitive advantage, because earlier you said the low latency and now you have software agnostic. So you're making this really appealing as you have a very clear, rich history in motorsport of the simulators being deployed. How about from a traditional OEM that's going to build a car that you and I might drive or ride? And how are traditional OEMs using your simulators?
So traditionally in automotive, simulators have been used in the past for things like vehicle dynamics and handling. So often when trying to set up the behavior and the performance of a vehicle, they would use simulators to simulate those elements. But the simulators are being used more and more now in automotive development. So one of the things that's happening, general trend in automotive is we see some changes and some reduction in the number of cars being bought. There's lots of questions over different types of powertrain being used. And so one of the things the automotive manufacturers are trying to do is to get new vehicles into market faster and cheaper. So traditional Western development cycles for a car run anything from 5 years to 7 years from attribute setting to get them into production. A lot of the Chinese manufacturers now are doing that in 36 months, and they aim to get them even quicker. So to stay competitive and stay flexible, a lot of the automotives are looking at using simulators to be able to develop those cars much faster. It also is a lot cheaper. So if you don't have to build 20, 30, 40 test vehicles, you can do it all in a digital realm. There's a lot of cost saving there, and that's a lot more sustainable as well. You're not flying cars all around the world to test in different conditions, and all of your departments can be working on the same virtual model so they don't get out of sync. Often when you do prototype vehicles, the vehicle dynamics guys will be doing one thing, then the powertrain guys are doing something else, and there are always compromises being met because you don't have the latest ultimate vehicle. Whereas if you do that digitally, you can all work in the same realm.
You have to, because the 7-year cycle is going to go the way of the dodo bird. It's going to go bye-bye because there's global pressures that are ramping up, and you're allowing that to accelerate. Are you seeing the OEMs, are they testing different engines, different transmissions, different suspensions? Are they putting all the ingredients in the pot and seeing what works best?
Exactly that. So, you might want to, say you're developing a hybrid vehicle, you may want to develop, how much electrical power do you use compared with combustion power? How do you mix them? How do they blend? So when you apply more throttle, when does the engine cut in? How smoothly does it cut in? Is there any transmission shunt in the development that you're doing? What's the vibration? What's the feeling there that you get? So that, that's just one example of how you can use a simulator. Haptic pedals and things like that. So, when you drive an EV and you're one pedal driving, having haptic feedback in the pedal is something you can simulate how aggressive that is. And then with the simulators, we can also do what's called software in the loop and hardware in the loop testing. So if you're developing a new control unit, for example, you can create that in a soft environment in something like MATLAB or Simulink. You can compile the code and then you can run that along with the driver in the loop simulator. So get the feedback, you can then alter the settings and see what the behavior is like and whether the test driver likes it or not. And then you can go the next step where you actually put the physical electronics with the code in it into the test as well. And then you're testing everything of the environment that you're actually going to put into the real vehicle.
So in summary, then that's a way for OEMs to accelerate the software-defined vehicle?
Correct, yeah. So they can not only that, they're doing that all in a safe environment, in a very repeatable environment, and you can do very easily do ABA testing and that kind of thing. So say you make a change, you can do a test, you can make a change, you can then compare the two, you can go back to confirm it, and you can do all that with a click of a button. If you go for an example with a road car, if you wanted to change the spring rates in the suspension, for example, if you were testing that in real life, you would go to a test track, you'd go out, you'd drive, get some data, you'd come back, you'd then have to have a technician take the suspension apart, change the springs, set it back up and go back out and do the test again. If you then wanted to go back and compare it, you've got to stop again and change the springs and go back out. And one of the problems with that is that every time you take time, the weather conditions change on what you're driving. It heats up. The tyres are different condition. So trying to do that quantitative A/B testing is quite difficult in the real environment, and you always end up making compromises. Whereas in the digital world, it's literally a click of a button and you can carry on your testing. So you can do the development very quickly.
From an economic standpoint, think about the test tracks are expensive. That's saving money, and some of them, as you know, get very bogged down. There's a long wait, so you're saving time and you're saving money there. How about autonomy? Can any autonomous or ADAS features be tested in your simulator?
Yes, yeah, certainly. So that's one of the things a lot of people say. You manufacture a driver in the loop simulator, but if cars are going to be self-driving in the future, why do you need a driver in the loop simulator? In reality, it's becoming a passenger in the loop simulator. So what's then happening is, needing to look at how do those autonomous systems behave in driving the car. So there's the whole safety scenarios that you can test, but then there's also the things, do you want the car to accelerate quickly? Do you want it to accelerate slowly? How fast does it go around a corner? How does the passenger feel comfortable? And then again, I mentioned about the sickness thing in the simulation world. Well, this is something that's going to be a problem in self-driving cars because, the first thing that people are going to be doing when the car's driving itself is they're going to be looking at their phone or their tablet or laptop. And the problem is then you're not looking on the road, you're not looking at what the motion is, and you're going to start to feel sick. So again, trying to make sure that the way the car performs to reduce that as much as possible is something you can test in a passenger in the loop simulator.
Because you see the same thing, and there's been multiple medical studies around certain electric vehicles, how they accelerate and individuals get that motion sickness where their stomach goes in their mouth. I would call it very similar to a roller coaster. Are those scenarios being tested as well?
Yep. Yep, exactly. So yeah, the harshness of acceleration, the braking, the cornering, all these things can be tested in the vehicle. And another good example, which everybody hates, lane keep assist. It's something that's mandated on most vehicles now, getting mandated on more and more types of vehicle. Everybody I know, I think, just says we want to turn it off. But one of the things you can do, with that lane keep assist, you can test how your lane keep assist is going to work. So, is it going to take a harsh reaction to drift in the car? Is it going to take that as a smooth reaction? You can test those kind of things with a demographic of drivers. So you can get good feedback across the board with different types of driver, different types of passenger, to put that into making your car, when you actually do put it into production, something that the custom consumer is going to like.
Can you test different sensor layouts, different configurations? Perhaps you have a LiDAR here, a camera here, or a radar here. Can you test that as well?
So there are ways of testing those, yeah. So what we have to do is to create basically dummy radar and LiDAR signals. So often the cameras can pick up what you would see in the visualization normally from our projectors or our LED wall. And then what we can create is a matching LiDAR or radar signature so that the sensors are picking up what they would normally pick up if they were driving on the road. So yeah, certainly that is, again, another feature that you can test.
Oh. When a customer purchases one of your simulators, do they have to build a warehouse to operate this? What does that look like when it's installation day? I call it excitement day. What does that look like?
So we have a range of simulators. Our biggest simulator has a 5x5 meter travel, so X and Y, and has unlimited yaw. So what that means is it gives you the ability to do one-to-one lane change testing. So if you're, for example, driving down a highway and you want to do a maneuver that takes you from one lane to another, either quick or slow maneuver, it allows you to do that in what we call one-to-one queuing. So it's the same motion. What that means, though, is from an installation point of view, you actually need a 10-meter diameter screen, which is a full 360 and is about 7 meters high. So it needs a fairly high building, and it needs to be a fairly sort of like a minimum of a 12 by 12 meter cube to fit the simulator into. But we work very much with our customers and our customers' facilities departments to help them make sure that everything that's required is ready for when we do our install. We install the systems on the customer site and fully commission them. And then we support the customer on their whole journey. So they have the ability to come to us with any questions that they have if they're struggling to integrate a new vehicle model, if they want a different track or a different test scenario. We work with the customers all the time, even once they have our simulators, to help them on the journey and act as a consultant for them as experts in simulation.
How does the model work? The customers buy a simulator from you, and then I'm going to give you a video game analogy. Forensic racing, for example, you buy different add-on packs, different tracks, different cars. Is that how that works?
Pretty similar with the tracks. So, for example, if a team is racing in Formula One or Formula E, they generally will want to buy the tracks that they're going to be racing on. So they may, and then if the following year a new track is introduced, generally they will come and buy the LiDAR scan and the graphics for that new track so that they can test on that track. So yeah, just like with your gaming, it's similar, but a different scale.
So Dynisma, you'll go out there and you will LiDAR precision map these tracks?
We work with partners. We're the motion provider. So we work with some of the software guys they go out and LiDAR the tracks and create the visualization. And we then integrate that with our motion platform. So we resell those tracks to our customers and support them on it.
So that's awesome. So that's the racing. And then, as you know, there's the controversy where you have the Motorhead. No, there's no way we're going to put an electric in here. No way, Jose. We're gonna keep the motor oils going. Can you different EV battery life scenarios, both from a racing perspective and from a consumer perspective?
Yeah, so with EV batteries, there are ways you can obviously model the battery and get performance out of it. And you can do static testing around things like WLTP cycle and some of the standard driving cycles to see what range and performance you're going to get. What those static simulations don't give you is the variability of the driver. So those models are kind of standard tests and what benchmark the battery performance and mileage range that a vehicle can do. However, if you then do the simulation with using a driver in the driver in the loop simulator, what that then does is adds in the driver element to that as well, and the variability in the driver element and how the driver, reacts to different things. So even if you have a road car driver driving the same journey to work every day, they'll do it different every day because it depends on how they're reacting to traffic, how they're reacting to things around them, how they're feeling, what music they're playing. We all drive different ways. So having the driver in the loop gives you that ability to really test an EV vehicle to the same extent that you would potentially a real vehicle in a real scenario, rather than using some test validation data that would be done, such as a W2P cycle or something like that.
And then you have emotions. Yesterday, coming home from the grocery store, and the truck pulls in front of the guy goes right around and pulls right in front of it. Those different emotions and the way the aggressive driving versus grandma style driving weighs on the battery.
Yeah, and there's other things as well. I mean, we talk about that there, but there's also, you can do things in the simulator like look at tiredness and things like that with a driver and do it quite safely in a test environment, because if you try and test tiredness in a driver in a real vehicle, you're putting it into quite a dangerous situation. Whereas with a simulator, you can get people into a state of tiredness and you can then try them in the simulator to see how their reactions react and how they react to different scenarios and different things that happen. So, there's lots of abilities to do things you wouldn't want to do in a real world vehicle or environment because of the safety side of it as well.
On that front, we have an epidemic in this country, distracted driving. Not one day goes by that I don't see somebody staring at their phone driving. Are your customers testing those various different distracted scenarios in the vehicles?
Yeah, and also the safety systems around them. I mean, a lot of vehicles now are looking at eye scanning technology to look at, where are you looking, hands on the wheel and all those kind of things. So obviously you can test all those different types of scenario in the vehicle. And as you say, if you're distracted. And the other thing that, not so much around distraction, but around things like HMI and layout in the cabin. So one of the things that the automotive manufacturers are quite keen on is looking at, what does the interior of my future vehicle look like? Now, we can actually do that with virtual reality. So we can put on or mixed reality. So the driver can wear a headset, and we've developed the ability to, for example, see the driver's hands and steering wheel and dashboard, but then everything else outside the car is in the virtual world. So you could be driving around the streets of Paris, for example, sitting in the simulator, seeing your normal hands and control systems and everything as if you're just driving on the real world scenario. But we can then also change things like the center console. So we could change the layout virtually to say, this is where the air conditioning button is, or this is where the radio button is. And you can then test the ability of the driver and how they're distracted when they go to move, affect the controls in the vehicle. So it's a very good, especially with the mixed and virtual reality, it gives you a really immersive experience of what a future car may feel like and look like before you've even cut any metal or molded any plastic.
Which is cost saving, because there's this debate rages globally: European automakers, Japanese automakers, American automakers, even Chinese automakers with the HMI, button versus screen. And there's a certain group of engineers and customers, I want the buttons. People like me, no, I just want the screen because the software updates and gets better. Are those scenarios being tested as well?
Yep, exactly that. So the kinds of controls, the buttons, the switches, the touch panels, all those different scenarios can be tested. So and the layouts and things like that of what they look like and how big how big is the button? Is the button on the screen big enough? Is it not big enough? Do we need an armrest to or to rest your wrist on, or as you're using the controls? Steering wheel layouts as well. So how do the buttons on the steering wheel work? What's good? What's bad? All those kind of things you can test either completely virtually or with a mixture between virtually and real life. And then if you go back to motor racing, one of the key things with motor racing nowadays is obviously the cars are really complicated and the controls for the drivers. If you look at a Formula One steering wheel nowadays, the number of buttons and switches and dials that they have, as well as even in World Endurance, they have switch panels with multiple functions. Part of with the simulator is getting the driver familiar with which button do I press, which control do I use, and making that second nature to them, so they're not having to look at the steering wheel to figure out which button to use when they're racing 20 other cars around Monaco street circuit.
Yeah, if you're running Monaco and you have to look at the buttons, you're in.
You've got You've got a problem. Exactly.
Yes, Prince Albert might not invite you back to Monaco. Simon, it's very clear that simulation has an extremely bright future. It's very clear that, in my opinion, we're just scratching the surface of what truly can be accomplished with simulation. In your opinion, what is the future of simulation?
I think what we're going to see is more and more digital twins in reality. So creating digital scenarios and digital environments that allow more and more both development and, from a racing point of view, more and more performance to come out of and closer racing to come out of the use of simulators. So I think, there's a really good position for simulation in automotive to make cars active safety systems, self-driving systems, the whole testing and scenario of that, being able to get vehicles that consumers really want into market that much quicker, and then to even further the development of those. So, you mentioned like over-the-air updates and things like that, being able to do those even quicker because you can very quickly put them in the simulator and test the scenario. Does that software patch that you've just done or that software upgrade actually work, or has it caused any other problems? You can do that development much quicker. So consumers always wanting updates, upgrades. Your iPhone gets updated on a regular basis. You get new apps, all those kind of things, and that's what customers want to see in cars nowadays. It's demanding those upgrades and the more features that they want. So I think, simulation can play a major part in that, in making the cars safer, getting them to market faster, and giving the consumer something that they really appreciate and they really want. And then on the racing side, it's going to make it more competitive, closer racing, give teams an edge, give that, but also a sustainable edge. So rather than currently taking combustion engine cars all around the world to test them at racetracks, you can do a lot more of that in simulator world where, we don't create the same greenhouse gases that you do in testing.
Yeah, if you look at the iPhone, the iPhone changed our world for better or worse, depends on who you speak to, but it got us accustomed to consistent updates. And that's what the consumer wants. And that's where simulation is going to allow the OEMs to meet this consumer demand. And as you clearly stated on the race side, it's going to make the drivers better. They're going to perform better. And from a fan's perspective, it's going to be really fun to watch because it's almost perfection. Some of these drivers are just incredible today with the skills that they have. Simon, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
I think it'd be really good if you just understand, that we're now using simulation to develop products both in racing and in automotive that are getting things to market quicker, getting you the features that you want, and really making things happen that much faster, cheaper, and in a safer, cleaner environment. I think as well, on the consumer side, you're starting to see more virtual reality being used in the consumer market, people gaming with more virtual reality, lots of people doing online gaming and sim racing as well. So, that's the other end of the simulation market. So I think not only in cars and automotive, but then just in general household things and that kind of thing, we're going to see more and more use of virtual reality and virtual environments. So I think it's just watch this space. I think the development is going to keep increasing. The stuff that's coming out, as I said, in our world and in the general consumer world is going to just keep growing, I think, going forwards.
Simon's 1,000% correct. Simulation growth is only going to accelerate as we get more and more digital twins. It's going to be more and more fun for what can be built on that. Today is tomorrow. Tomorrow is today. The future is Dynisma. Simon, thank you so much for coming on SAE Tomorrow Today.
Thank you very much.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week as we speak with the CEO of Fusion Processing about their SAE Level 4 buses.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.